Even roots. So our next parent function. Even roots are going to either use this radical notation or they're going to use an exponential notation with a rational number, 1x to the 1 over n. And in either case there, the n is an even number, which is why we call it an even root. Our arrow diagram, we'll go ahead on this one and use the nth root. And this one's going to look a little bit different because there are some things that we just can't put in here. Okay? If I try negative infinity, I'm just going to put a line here because there literally is nothing there. So I'm going to jump to 0. 0 in gets us a 0 out, a 1 in gives us a 1 out, but to get a sense of the shape of this thing, an n squared is going to give us an n out. Scratch that last bit, I've taken that off of there. What is actually going to happen is a 2 to the n is going to give us a 2 out. That's what's going to help us to see this shape. And infinity n is going to give us, is going to head to infinity. So as we go to infinity on the positive x-axis, it also climbs to infinity. Okay. So the points that we need over here, we need a point at 1 on the positive x and on the positive y, and we'll have some point out here that will say this is 2 to the n, and this will be 2 on that one. And so our points at negative infinity out here, that would be a negative number that we're trying to take an even root of, multiply a number by itself an even number of times to get a negative. We can't do that in the real numbers. So the first place that we can get it is with a 0. And so these are going to tend to look like this. They're going to have this kind of shape. You'd be very correct to say it sort of looks like half a parabola laying on its side. It absolutely does. And it absolutely is. That's what that looks like. Either from our list here or visually from there, we can fill in our domain and range. The domain here, the only x values we can use are x's that are greater than or equal to 0, and for outputs we end up with y values that are greater than or equal to 0. And so our description, we only have n behavior on one end. Our other one's completely described by this point 0, 0 that's on there, but if we were describing our n behavior, we would say that as x approaches infinity, our f of x here also approaches infinity. It doesn't go there super fast, but it is going that direction, and it's getting there faster than our logarithms did for certain. Okay. And I believe that is about it for the even root parent function.